Hello, thank you today for joining the AWWA webinar on managing water loss together. 3 utilities share their strategies and lessons learned. I'm Travis Smith. I'll be your moderator for the day. Before I review our agenda today, I wanted to share some tips on the AWWA webinar. So please close all email programs, instant messengers, other programs not in use. At any time, you can refer to the GoToWebinar support at the URL listed. Technical assistance can be found here at any time. After the webinar ends, immediately following, there will be a survey. The survey window opens automatically. We appreciate your support and feedback on the survey. As a note, the AWWA does not endorse any products represented here. It is meant to be educational and for all members of the audience and beneficial to use as a learning exercise. I wanted to introduce our panel of experts today: Mark Moore from the City of Fairmont, West Virginia, Sean Stoddard of Truckee Meadows Water Authority, Mario Leone of the Borough of Monaca. At any time during the webinar, you may submit questions to the broadcast using the question pane at the lower right of your screen. We will answer questions at the end of the webinar. Please, if there's a specific panelist you would like to answer the question, please note that with your question. So going forward today, water loss is a significant issue for most water utilities today. Water loss can have a significant impact on the sustainability of water resources, customer service, revenue, and operational costs. Today, we'll hear from 3 utilities on how they've been able to identify water losses and improve their operations. Mark Moore is our first presenter. He is the utility controller for the City of Fairmont, West Virginia. Take it away, Mark.
Thank you, Travis. What I've put together today is a discussion on the overview of our water board organization, a discussion on the AMR project, what we have learned and the benefits of the system after we put it together. I'll go over in detail the continuous usage or continuous consumption report. I'll also discuss inactive with consumption, the reports and the alarms that are on the system, go over our billing schedule, and also talk about our META testing at the end. Next, please. The City of Fairmont is a regional provider that provides water to 5 counties. We have 10 resale customers. About 50,000 people a day depend on our water. We have approximately 14,000 meters in our system. We produce 5.2 million gallons of water a day and 2.2 billion a year. And we presently utilize either a 30-day billing cycle for our larger users and a 60-day cycle for our residential. When we implemented the AMR project in 2013, we anticipated it taking about 3 or 4 years, and it did meet that schedule. We have about 4 meters left to put in the system, and we'll be up and running. As I stated earlier, we have 14,000 meters. We have also put in 5 TGB towers, 2 echo repeaters. We utilize the census software of Logic and RNI. Our field personnel use the Trimble Nomad units as their handheld equipment, and we are a census-hosted system. During the implementation, the city became aware of the following things. First of all, we had learned that 120 customers were identified as receiving free service. This is quite common with the fact that we are a university town, had a lot of rental properties. We learned of a lot of inactive accounts, and along with finding this out, we also learned that our shutoff procedures had some issues involved in when we turned people off, and it had caused some customers to still be on when we weren't aware of it. We also found that our basement and our inside reads for our customers were not as accurate as they could have been, because we were having to estimate quite a bit. However, we did find out that our meters that we took out of the system, only about 5% of them were testing below the standards. So that was not a bad scenario. One of the best customer service tools that we have found at this point is the report that you see here called continuous usage. On the left-hand side, it shows where you can go underneath validation parameters, and then you can pick the continuous usage report in the center in order to get to the next screen. Next, please. When you get to this screen, you can then set up the defaults for each meter size that will allow you to monitor your customers for continuous usage. Underneath the validation area, you get this screen, and you can pick, for example, at the end, you can pick a 5/8 meter, and then over underneath parameter number 1, you see where it says 48. Well, we have since changed that to 24, and what that allows this to do is if a customer shows up to have continuous usage for 24 straight hours, it shows up on this continuous usage report. Next, please. Underneath the report section of the software and meter exceptions, you can go down and pick the continuous usage consumption report. And when you go into the center and pick your meter size, as in this case, we picked 5/8 inch meters and hit go and submit, we found that 71 customers have continuous usage within our system that have a 5/8 inch meter. This allows us to go in and determine their usage to find out how bad that leak or their potential problem could be. Next slide, please. If you clicked on the green link on that last screen, you will go to a specific customer, and you can see the hourly consumption that is being taken place at this customer's facility. And that way our staff can go in and we can contact the customer, and I will go over that shortly, exactly what we do. Next, please. Before we had this report, and in the past, a customer could go weeks without knowledge that they were having continuous usage. With a 60-day billing cycle for residential users, plus you add on the mail processing time, you can see that the time factor could be very large. Also, on times of the year in the winter when you're not even able to go out and read the meters, we were estimating, and therefore we were not finding that leak when we estimated. So a customer could literally go months before they knew this. What we have chosen to do at the City of Fairmont is at any time a customer gets on the continuous usage report, then we wait 3 days to make sure that there is a problem at the home. Sometimes the customer could find a faulty toilet, or they might find something on their own accord where the water was running. Next, please. What we do as a standard operating procedure with this continuous usage report is after 3 days, if a customer is running under 30 gallons an hour, we notify the customer via email or we send them a letter. If it's over 30 gallons an hour, a meter tech is sent to confirm the problem, and then we try to attempt to make contact with the customer. Now, if it's over 100 gallons an hour, we quickly move to be able to notify the customer as quickly as possible. When we implemented the continuous usage report, earlier I showed you where there were 71 customers on this report. And when we first started, there was 700 customers that showed up on this continuous usage. Now, during the winter months, presently we have about 50 on that report. But during the winter months, a lot of times we just pay attention to the 30 gallons an hour and up because a lot of customers leave their water on in the winter to keep from freezing up. One of the things that we have learned from this particular report that has, because of the fact that we can notify the customer so quickly that they can find their leak and deal with it in a more timely fashion, the residential consumption in our system is down 25 million gallons for the year. And because of that, the positive feedback that we're receiving from our customers because of this timeliness of notification and also the consistency of their reads, it is really a wonderful customer service tool to help folks out to allow them to be notified a lot quicker on these leaks. From a staffing level, Obviously, when we had 700 customers, it took quite a bit of time to get this dwindled down. But presently, when you're looking about 50 to 75 on the report every day, it takes a staff member about 45 minutes to an hour on a daily basis to handle this process. In the same area as the continuous usage report, there is also an inactive with consumption. This report allows you to find the customers in your system that presently are inactive, but their meters are turning. A lot of times we are very careful with this because being a university town, you can have a lot of landlords that are quickly cleaning up rentals or things of that nature. So the area to the right where you can go to the green area and drill down to the customer level, it is very helpful in order to make sure that it's something that is consistent for a long period of time, and it's just not one night where they've taken a few gallons of water and cleaned up the home. Next, please. Some of the other things that the system allows you to do, and a lot of it is still done in that same parameter and validation area and under the meter exception area, there are reports and alarms that allows you to use it to be able to handle possible issues that are in the field. For example, the register increasing report can be set up to allow the resident to be on the report if the meter is not flowing in the correct direction. It also sends out alarms for an empty pipe indicating there's no water in the line. And then an item also that you can locate is a meter communication failure, which usually indicates that you have a cut or a bad wire between the meter and the radio. Moving on to our billing, we utilize a system to predetermine what our non-reads are. So a week ahead of time, we go into the system and get a reading request to find out which customers have not been sending a good signal, which we don't have a read for whatever reason. There could be an obstruction on the radio. We could have a product deficiency. There could be tampering. There could be a programming problem. Any of those things that can happen, we want to investigate as soon as we can. The first thing we do when we get the non-reads is we go into the R&I and see if we have anything over the last 4 or 5 days. And if we do, then we know it's not a consistent problem and we could possibly have a read within the next few days. But if we find that we don't even get a read in the R&I after we've tried in the logic, then we dispatch somebody to go out in the field to see why we cannot get a read at that particular location. Next, please. Now, due to the availability of our reading personnel who are no longer out reading meters every day, we have started a very intensive meter testing program. In the past, the meter testing was very sporadic and the information that was available was very limited due to our availability of personnel. So in 2010, we began learning to find out what our usage levels were on both a monthly and a yearly basis. We developed a spreadsheet to track this consumption for the last 4 years, and we utilized a 25,000 gallon a month process to determine if that customer would be monitored on a consistent basis. Also, as part of the meter testing, we began by purchasing Omni meters to replace some of our outdated meters in the field. We also purchased a test meter so that we could do our own meter testing, and we implemented that while parallel testing with our local census distributor. We were doing that over the last few months on a little bit of a sporadic basis, but we have definitely increased it since we finished the AMR project over the last few months. And the results of this testing is surfacing. As you can see, our consumption has increased 4% since 2014 on our larger users. And as I just stated, with the project complete, we are testing a lot more. And the pie chart at the bottom represents the percentage of our consumption. And this is why, in my case, it was so important that we started a meter testing program, because you can see in the green areas that 47 meters make up 53% of our consumption. And then the next 180 make up 15%. So you've got 227 meters that are almost making up 70% of your consumption. We definitely want to be able to monitor those and make sure that they are working at the best percentage and accurate percentage as possible. Next, please. The program we set up in our case is detailed in the following. Twice a year we check our resale customers. Twice a year we check any customer's meters and test their meters that they use greater than 1 million gallon a month. We do annual testing of any meter that's over 2 million gallons a year. And every 3 years we get a third party to come in and test the meters alongside of us to make sure that everything is being done correctly. We have our test meter calibrated annually. All meters that are greater than 1.5 inches are tested when we install them in the setter to make sure that they're going in as an accurate meter. Any work orders or purchasing that is done for any of these larger meters must go through my office so that we can maintain control of what we're buying and where it's going. I have a special inventory person that keeps track of these large meters, both incoming and outgoing. And then any time that we have a new customer coming in that wants a large meter, then that meter application not only has to be approved by our engineering department, but we also get our distributor involved to make sure that they are comfortable with the setup and feel that it will maximize everything in our system. That completes my part of the webinar, and I appreciate your time.
Thank you, Mark. Those are some valuable lessons learned on customer service, and what a great story of redeploying your workforce to find some non-revenue water within your system there. It's quite an impressive gain of 4% revenue. Moving forward, our next panelist is Sean Stoddard. Sean Stoddard is the Senior Resource Economist for Truckee Meadows Water Authority in Reno, Nevada. Take it away, Sean.
Thank you, Travis. Just to give everybody a little bit of background here, Truckee Meadows Water Authority, we're located in Reno, Nevada. We were created as a government agency back in 2000 to purchase the private water utility from Sierra Pacific Power Company and to operate that. And we currently serve the cities of Reno and Sparks, Nevada, as well as parts of Washoe County. And as you can see on the map, we're actually located just a little bit northeast of Lake Tahoe. And currently we're serving about 385,000 people in our community. Next, please. We currently have about 119,000 active water services and a staff of about 200 employees. And what I talk about here is how up until about 2007, 2008, our production was increasing peak day, and then we went on a path of not just looking at how do we recover lost water, but actually looking at customer behavior and how we can get their behaviors to change. That actually recovered operating capacity and reduced peak day. So one of the things that's kind of interesting for our area is in the wintertime, we have almost no outdoor irrigation, so we're producing about 30 million gallons a day. And then we peak in the summertime to about 120 million gallons a day. And our peak day production was actually about 148 million gallons a day back in 2005. From 2001 to 2007, we were averaging about 142 million gallons a day peak production. Next slide, please. So this is a little bit more on the conservation side, but as you'll see, it impacts operations considerably. We've always been very conservation minded here in the Reno area. It's been a priority since the 8-year drought from 87 to 94. And for our area, multi-year droughts are not uncommon. And up around 1996, half of our water services were actually flat rate water services. They did not have meters installed. And about that time, 2-day-a-week watering schedules became required, and we had to maintain that schedule until at least 90% of all the flat rate single-family homes had meters installed. And that was happening in 2010. We reached that goal. And so at that point, we were able to look at, can we change the assigned day watering schedule to something that benefited utility operations. Next slide, please. So in 2003, we started collecting data on water use at the daily level. What we were doing, we were using our drive-by system every night, sent drivers out collecting the same data from the same homes every night. And now we're using census system and some meters with data loggers, FlexNet, to collect both daily and hourly data. And currently, about 31,000 customers we're collecting daily data on. That's about 26% of our customers. Next slide, please. Now, in 2008 and 2010, we embarked on what's kind of considered a landmark study, Freedom to Choose, where we looked at changing the assigned day watering. And we did a study partnered with the University of Nevada, Reno. In fact, the study started off as a PhD student's dissertation. And what we were looking at is how effective was twice-a-week watering schedule. Could system operations be improved by changing the schedule, and will changing from twice a week to thrice a week lead to greater conservation? Next slide, please. Here in Reno, what we have is, with the assigned day watering, this graph shows a very typical home, is we can very easily identify days where people are irrigating outdoors, and then we can see the non-watering days, the indoor water use quite clearly. Next slide. Just to kind of give a little bit of a background here, on the left of your screen, week types in 2008 is we saw about 25% of our customers were watering on the 2-day schedule. The middle bar, these were customers that were sort of watering on 2 to 3 days a week. They bounced back and forth. But then we saw with the next bar over, about 40% of the customers were actually watering 3 days a week anyway. So enforcement wasn't really happening. People were saying we're going to water 3 days a week. And so in 2010, when we changed the policy, we had a number of people that stayed on a 2-day-a-week schedule. And then you could see about 55, just under 60% of the residents moved to a 3-day-a-week schedule. And then we had about 20% that found they worked fine on a mostly 2-day-a-week, occasional third day. So these were people who really kind of turned their systems on and off based on what they needed. So we saw a big change in behavior here by adapting to a 3-day-a-week schedule. Next slide. Now, one of the questions that came up was, if you allow people to water 3 days a week, would they use more water? And the answer was basically no. We looked at households in both years, 2008 and 2010, and this graph, the water use is measured in tens of gallons. And if you looked on that graph, the dashed line is the weekly water use. And so you can see the amount of water being used in 2008 and 2010 did not change, but the black line there shows clearly a change in their daily water use pattern. We have a no watering on Monday policy here in the Reno area, and so what we see is that peak water use clearly went down. Weekly water use didn't change, which is kind of important from a revenue perspective. We still want to sell water, but we want people to use it more efficiently. So next slide, please. So here also people on a water schedule. I make sure Yeah, the previous slide was everybody. Here we have people on a strict 3-day-a-week schedule. We see the same pattern, even people who went strictly on a schedule. Their weekly water use did not change, and we see a reduction in their peak water use. And next slide. And these are the people who basically did not water on a schedule. And we see that they use a lot less water. So no real changes in behavior here. They started to use a little bit more of a schedule. But the takeaway story among these three graphs were by going from twice a week to 3-day a week, we reduced system peaks, sold basically the same amount of water, and freed up a little bit of capacity. Next slide. This graph here kind of shows the takeaway in terms of what actually happens between having a assigned day schedule versus no schedule. So if people were using 2, 3, or 4 days, so if they were on a water schedule, as you increase the number of days, their water use actually went down. If individuals were not on a schedule, overall they use less water than people on a schedule. But as you increase the number of days, their water use goes up a little bit. So yes, adding more days sort of increases the amount of water used if nobody is on a watering schedule. But having a watering schedule, while it increases a little bit of predictability in the production process, it did lead to reducing water use by going from 2 to 3 days a week. So it was actually, so it worked out really well for us, going from 2 days to 3 days. Next slide, please. So the conclusions from the work that we did was having a strict assigned day watering schedule does increase water use compared to not having any schedule. Without a schedule, increasing the number of watering days does increase weekly watering use, but with the schedule, increasing the number of watering days will decrease weekly water use. And then using daily consumption data to understand customer behavior can lead to policies that have the ability to improve operations. And as a result of going from 2-day a week to 3-day a week, we have actually reduced our peak day by almost 20 million gallons a day, which is a substantial improvement. Next slide. So what are we doing today? Currently, we've automated collection of daily and hourly water use data on about 26% of our customers, and that's expanding. We're using newly collected daily data and updating our 20-year water facility plan. We're going through a process now of updating the analysis on our conservation programs. And we're also starting to look at developing abnormal water use detection programs that can help us to spot problems ahead of time and notify customers. Next slide. Now, one of the things that's probably helpful, and this is what I tell the utilities, is these are things that you guys can do right now. One of the things is start collecting data on your customers from your billing system and your meter reading. Almost everybody can do that now. In getting this program started, I became friends with University of Nevada, Reno. This whole thing started with a grad student just looking for some data. And it turned out to be very beneficial to both us and the university. So there might be a little bit of effort, but you can really get some benefits there. And you only need one friend at the university who might be willing to work with you. Then the third thing is have a multi-year plan for collecting and saving the data. I've had a lot of people say, well, it's an awful lot of data to be collecting, but in reality, our entire data set for most of these studies will sit on a $15 flash drive. So you collect the data. The data is good for a number of years. I'm still doing work on data that's been collected over the last 10 years, and we can still get very useful results out of those studies. Next slide. And that's the highlights of one of our key studies with regards to modifying customer behavior and using that to get better use out of the water that we do have. And thank you guys for your time.
Thank you, Sean. Those are some great data and measures of ensuring and driving water conservation. Certainly a key topic for our Western audience and some of our audience in Texas and Florida, where water resources continue to be constrained. I want to remind the audience to submit any questions during the broadcast using the pane at the lower right at any time, and we will answer those at the end. Our third panelist is Mario Leone, who's the manager of the Borough of Monaca, and Mario will share some great experiences from the Borough of Monaca. Take it away, Mario.
Thank you, Travis, and good afternoon. I'm both honored and excited to be able to present the Monaca story to everyone today. And before doing so, I would just want to give an applaud both to Mark and Sean for their presentations. Mark, you're running a remarkable operation there. And Sean, I just have to say I'm glad that I don't have the issues and concerns that you have to deal with out there. You know, water loss, depending on how you look at it, can be a really wet topic or a dry topic when you're looking at conserving and tightening up your system. And I feel I need to share my morning breakfast coffee with you all here. I'm having my coffee, and my wife asks, so what do you have going on for today? And I say, well, I got this great opportunity to share the Monaca story with over 600 people. And would you have ever dreamt that I would be doing this? And she looked at me kind of seriously and she said, honey, you're not in my dreams. So, and moving on. So the agenda and objective that I want to share with you is the benefits of implementing innovative technologies for a more efficient operation. I'm going to provide you a background on the Borough of Monaca and show you that it doesn't matter what size you are to succeed. It's the amount of will and determination you have to succeed. Then I'm going to talk to you about our AMI water meter and leak detection systems and how you can't manage what you don't measure, and you can't measure what you don't manage. And then some future initiatives, but quite frankly, Mark did such an outstanding job on explaining the benefits of the Logic software and the SaaS software services. I'm just going to kind of skip over that and just echo his comments. And then I'm going to share with you some closing remarks and a challenge. Next slide, please. So Borough facts. We have population about 5,737, households 2,461, or approximately 2 square miles. So as you can see, we're a pretty small town, but we feel that we're doing some really, really big things. And our tagline is leading the way. Next slide, please. As you can see, we've received numerous awards over the past 5 years. And my personal passion and purpose is sustainability and innovation. And last year we won the Census Reach Award for customer conservation. And Census has truly been a vital partner in a lot of the borough awards that we've received. Next slide, please. Oh, let me talk to you about the importance of innovation. I would like to reference the Tic Tac. And for full disclosures, there's no correlation with my last name, Leone, and the Italian manufacturer of Tic Tac. I'm not receiving any royalties. I don't own any stock in it. And so I'm not getting anything from Tic Tac. And for that fact, nor are there any royalties from Census in this presentation. Last year, Tic Tac unveiled their first innovation in 7 years after an 18-month study. And they determined there's 3 reasons why people eat Tic Tac. One is to freshen their breath, a sweetie, fruity moment, and an emotional rescue. what they found out in the study was that our millennial population, they get bored in less than 1 minute in eating a Tic Tac. So they developed this changing flavor Tic Tac, the cherry cola, and my favorite, the peach lemonade. So like the candy industry, we in the water industry, we must also be innovative. Next slide, please. So the AMI meter reading and leak detection system that the Borough of Monaca installed in 2010, we replaced 2,438 meters to a fixed-based advanced metering infrastructure. We have one antenna propagating our entire system. We also installed a system-wide leak detection management system, which Sensus partnered with Fluid Control Systems, FCS. And we installed about 150 of the permalogs. Those are in the picture in your lower left-hand corner throughout our system. And we also installed a new billing software system as well. Next slide. So embracing new technologies. How has Monaca been able to do this? We eliminated the because factor, the 8 most expensive words in business, because we have always done it that way. You know, how many of you have heard that? You know, why are you doing it that way? Well, that's the way we've always done it. And, you know, we just put a stop to that and we looked at, is there a better way of doing what we're doing? So, you know, if we would have stayed the old way with the old register, and instead of, you know, moving to a higher, you know, technology with the computerized, it tracks your inventory, helps increase productivity, it provides useful information, it improves our billing accuracy, the ability to store useful data, and then most important, it saves money. And not only does it save money, but it makes money. As Mark indicated in his presentation, when we implemented our meter changing program, we actually found that we had 200 accounts that were purged for our system for various reasons. And like Mark, we have a lot of rentals. We found errors in our shutoff procedures. And this was a great addition to boosting the revenue in Monaca Borough. And it amounted to almost 10% of our accounts. Next slide, please. So the cost benefits of modern technology through our system-wide leak detection system. Every morning, my utility clerk runs this report that you see. And with logistics, as Mark indicated, a lot of this processing would be done automatically. It would generate this report. It will email it to each individual that needs to see it. We're currently, it's a little laborsome where my clerk has to come in, generate the report. It takes about an hour right now. But what does this do? You look at the map and where the red flags are, it's indicating areas that we have potential leaks in the system. So we would then go in and hone in on those particular red flags, and I'll show you that in the next slide. But you know what it does is it reduces the time and expense of labor and equipment and transportation costs. You're not driving around through your system trying to search for leaks. This technology actually, you know, pinpoints you to areas that you need to be looking at. It reduces your restoration costs by pinpointing leak locations. We have found that through our correlator that we are locating our leaks within 3 feet, and many times we're within 1 foot of where the correlator directs us. We're also reducing our treatment costs by lowering chemical, electrical, and equipment expenses. And in the future slide, you'll see the tremendous benefits from this. And it reduces your liability costs by minimizing the chances of seek holes or washouts that you don't know are occurring. And just overall, it truly improves the customer confidence in the system that you're operating. Next slide, please. So when you click on one of those red flags, it takes you to that specific location and you get a readout that depicts like this, and then you'll see the red arrows that are showing how you know, bad the level and the spread of the leak, and the higher that bar, obviously, the more significant of the leak you have in your system. So we'll prioritize them, and obviously those that are leaking more water, we tackle those ones first. And next slide. And we'll go out to the system, and then we hook up our correlator, and then we put one of the nodes on each of the valves in that area. This picture here is depicting fire hydrants, but we utilize water valves. And you let it run its diagnostic tests, and then it'll put out a read back to you and say, From valve L1, it's so many feet from that point, and then so many from L2. You wheel it off, you spray paint your X, and do your PA1 call for dig, and typically we are within 3 feet of that mark, and many times we're bullseye. So again, tremendously reducing restoration costs where you see the water percolating from a particular area, so you dig where it's percolating to find out the water may hit a vein or took a different route, and you're actually chasing the spot repair. Next slide, please. So, the remarkable story that Monaca has to tell is here that the 14th Street waterfall, and which actually was a water leak, we had estimated that over 100,000 gallons a day was lost through an 8-inch full circle split. This little kind of hillside ravine flowed with water for over 20 years to the best of our recollection. Shortly after deploying the system, it was telling us we had a leak up in that area, and we explored it and we repaired the leak, and the waterfall dried up. Again, just a tremendous amount of water loss and cost to the borough. Next slide. So this slide shows you from a revenue standpoint, after we completed the system in 2011, our baseline, our revenues went up, and our revenues went up due to the addition of 200 meters. Also, the meters reading more accurate than many of the old meters that we had in our system that were 20, 30 years old. And there's also a little component in each, I think it was year 2013, with a slight rate increase. On expenses, our utilities and energies, from our baseline of $104,000, you see that we've averaged approximately 40% savings in each of the respective years. Our chemical costs also went down approximately 45% over those 3 years respectively, and overtime went down 30%. And looking at 2014, that data is skewed. We had a employee that was off on a workers' comp, which generated some additional overtime. However, our straight wages, and that was down 18,000. So we're greatly reducing overtime because we're fixing the repairs. We know the water leaks before they surface. Next slide, please. So innovation is as simple as tic-tac-toe, 3 wins in a row. It saves you money, it conserves water and protects our environment, and then the operational savings and being able to predictively maintain your water leaks instead of being reactionary to waiting for them to surface. Next slide. And my closing remarks and challenge, you should not be asking yourself, how can you afford to do this? Please ask yourself how you can afford not to be doing it. Now, my challenge to you is to go be an innovator and start implementing all 3, the Census FlexNet AMI system, the leak detection and conservation, and the logistics software system. Thank you for being an awesome audience. That concludes my presentation.
Thank you, Mario. That was a great story of deploying acoustical monitoring to identify leaks and some impressive cost savings within your utility. I'd like to remind the audience to submit your questions using the pane at the lower right of your screen anytime. While we're organizing these questions, I also wanted to share some simple resources for all utilities to help identify water loss and non-revenue water. So please take advantage of the free AWWA water audit software that is available. Participate in your water loss conferences and committees, and focus on measuring all of your usage and production so that you obtain a baseline so you understand what your production volume is versus your total billed volume and consumed volumes are within your system, so you can begin to identify those non-revenue water components. So I do want to turn it over to the question period here, so please add your questions as we go. We'll rotate through several questions that we received today. From Mark, have you received any feedback from your customers on being notified of a leak proactively?
Yeah, we have had quite a bit of that from our customers, especially, like I said earlier, when you can notify them in a matter of 4 or 5 days, what used to be 40 or 50 days. That has been, like I said in the presentation, two of the biggest things that we've gotten back is because of this FlexNet system, the consistency of the reads and the notification of their issues, either it be a leak or some kind of faulty appliance in their home.
Thank you. For Sean, an interesting question on have you explored the possibility of using your data for enforcement of irrigation usage when under water restrictions?
Yes, we're actually looking at seeing if the data does allow us to do that. We have conservation consultants that investigate complaints of people watering on different days, but at this point we found that most people are in compliance and most people are pretty satisfied, and they tend to water on 3 days a week anyway. So while we could do it, we hadn't had a burning need to do it yet.
Great. For Mario, a several-part question here. One audience member is curious as to the approximate project cost of the borough and how the project was funded.
Yes, our project, it cost approximately $1.4–1.5 million to implement. We did it through an energy performance contract with Johnson Controls, and basically the savings generated from the implementation and the increased revenue would pay for it. And you know, we are very confident that in that 14th Street waterfall, the water loss and the savings generated from that it was basically a home run for the borough of Monaca, and certainly paid for itself. It was financed over 15 years, and we believe with the additional revenue and cost savings that spread will be shortened probably to under 10 years in payback.
The next question, we'll throw it over to Mark, but we'll invite the other panelists to weigh in as well. How frequently does data need to be collected to be relevant? From an operation perspective, is real time better than daily? Mark?
Well, one of the things that we've done with the continuous usage report is a lot of times we find that person, and the logic system gives you the last read on midnight the night before. If it is a 100-gallon user an hour, or even anything more significant than that, we immediately jump on the RNI and see if it's still running. Most of the time, the RNI, we get that within an hour or two at the most. It's much more live because it is where the radio signal goes to prior to syncing with the logic system. And it has been very relevant where we've been able to get a hold of the customer timely, and there also are alarms on the RNI that can utilize as well, but we have been primarily using the logic system. And like I said in the presentation, we still have just about 4 meters left, so we're just now getting to the point where we can start playing with all this technology. But the real-time data is extremely important, and we utilize it as much as possible.
Great. Any other additional comments from Sean or Mario?
Just to echo, Mario.
Go ahead, Mario.
Just to echo some of Mark's comments, and the true benefit of Logix and having it to help process some of the data. We're still not to that level, so many of our queries have to be done manually. But having that data, and when a resident comes in and debates on whether or not they actually use the quantified amount that's on the bill, having those reads and data in our arsenal, justifies, and we can then, tell them that it appears you have something running during the evening, after looking up their file. But I can't express enough the value of the technology and having the reads, and then the Logix is just basically putting the system on steroids, so to speak.
Yeah, and I like to echo those comments as well in terms of the real-time data. When you're looking for leaks and you're looking to customer service to let people know they have a problem, that's really hard to beat. But then when you're starting to look at the planning and optimizing water use and behaviors over time, monthly data and daily data collected over a long period of time becomes valuable in that context. We do a lot of analysis on monthly data, and we've been collecting it for a number of years now. And then even the daily data, we archive that so that we can go back and do these particular studies and look at how we can help our customers get more from the water they choose to buy, and that helps in the facility planning process as well. So it really depends upon the need and the context, but real-time data best for dealing with leaks and water loss, and the long-term data for improving water use.
And one other thing too, Travis, is to go one step further, if I could just take a second, is, I've seen the customer portal that Census is getting ready to initiate, or has initiated, and we're just getting ready to start the implementation, where the customers can log in and see their own information on this system. And you can put alerts in there to notify you if they're running a certain amount of gallons that you don't think is relevant, or if it's running at a time that it shouldn't be running. When you have that kind of technology that can notify the customer what an insurance policy they've got to see that something's going on in their home that they're not aware of.
Great. So another question from the audience is directed actually at me, of where to find information on Permalog leak detection. You can find that information on the Census website or the FCS website, or through your local distributors. It further asks, is that a permanent installation? They can be deployed in a permanent installation, or they can be deployed with a lift and shift strategy. So those are useful devices. If there are any questions, we'll be happy to answer that going forward. Following on the questions on the permaloggers, Mario, there's some questions of how many loggers did you deploy in the system, and did you use an AWWA audit, and then what other leak detection equipment did you use?
Okay, our project consisted of getting 150 of the loggers, and we're deployed at about 146 or 7 of them that we have deployed in the system, and then we're just using the other 3 as backup, or if we need to go into a particular area and maybe do a little more comprehensive testing in that area. And what was the other part of that question? I didn't write it down.
What other leak detection equipment did you use, and did you use the AWWA audit software?
The other piece of equipment that we use is the correlator, that once we are pinpointed to a specific area to look at, we deploy the correlator, and it runs its test and provides its feedback. And as far as the AWWA audit, I am not confirmed whether we used that or not. I can look into that and email the answer that we can get that back to whoever.
For Mark, there's a question on, considering the large amount of flow through a small percentage of your meters, what criteria did you use in selecting those units?
Our meter deployment was specifically placed towards the Omni meter provided by Census. And I'm a bean counter, so I don't know a lot of the engineering behind it, but what I do know is the FlexNet system allows me to get hourly reads. The RNI lets me to get even real-time data in some cases. And as far as I know, the Omni meters are the one meter that you can calibrate in the setter and tweak it as you need to get the percentage as accurate as it can be. Because no matter how hard you try, no meter setter is in an absolutely perfect environment every single time. So having that ability to to manipulate, for an all intents and better word, was my criteria for looking at this meter. The accuracy is proven, and again, that calibration in the setter and the FlexNet system combined is why I felt we should go in that direction.
Great. For Sean, or possibly Mark and Mario, you can weigh in as well. The question is, how to determine if a meter installed years ago is the correct meter today?
That's a good question, and I would probably have to talk with the engineers on that one. We've recently, I'd say when we first became TUMLA, we went to a meter refresh program because many of the meters were very old in our system. So a lot of them have been replaced back then. And so we need to work with the engineering staff to really determine, the appropriateness of the meter. I'm an economist. I analyze the data coming out of the meters, so I really can't offer anything on that.
Okay.
Travis, I could maybe add a little on to that, and it kind of falls into my perspective, on innovation. Obviously, when you install a meter and you're looking to change it, probably 20, 30 years have passed. So you have to capitalize on the newer innovations that might make the accuracy of reading a little better. In the Borough Monaca's situation, we have a very hard composite of water and minerals. So when you have moving parts, the coagulation and buildup that occurs in those mechanisms, obviously is going to, weigh in the accuracy of that meter read over the life. So, when you look at the magnetic reading meters that don't have any moving parts, I think there's a lot of, good reason in looking to, transition, to a different technology. So, basically it depends on, where you're located, whether you have sand, hard water, different scenarios, and implementing those meter technologies that exist today that didn't 30 years ago.
Thank you. So I'll invite all three panelists to weigh in our final question here, and that is, what is the average acceptable water loss in the U.S.? We'll start with Mark.
Well, from our standpoint here in West Virginia, the Public Service Commission puts up a red flag anytime you're over 15%, and we're working diligently to get down to that part. I mean, there has been times our system's been upwards of 40% of water loss, and we have significantly dwindled that. And the leak detection program and doing the things that Mario has already talked about with the perma-loggers and the correlators, that is our next step. We've only dived into it very slowly, but I know it's dollars and cents. I can sit here and tell you if you lose 5% of your water loss, I can tell you how much money you're going to save. So with that being said, our goal is to get to the 15% and ultimately get down as low as 7 to 8.
Sean, Sean, we may have you on mute there.
Sorry about that.
Mario.
I was on mute. Well, our system, our engineers have estimated that we're down somewhere around 7% non-revenue water. And if I recall, a couple of years back, California was looking at you had to get that non-revenue water below that point before you can get additional water resources. So it seems like there's a direction here in the West to try to get that number as low as possible.
Mario?
Okay. Very similar to Mark. Our threshold is pretty much set and established at 15%. I can tell you that previously to installing our leak detection system, we had many years of over 50% water loss, unaccountable water. And I am proud to say that since the implementation, we've gotten it under 20%. I think the best that we were able to attain was 17% 2 years ago. And obviously our goal is to continue to reduce that, and I would love to be able to maintain it under 10%.
Thank you. And I want to thank all of our panelists for their valuable contributions and sharing some stories with their utilities and data and some success stories and lessons learned. On behalf of the AWWA and Census, I wanted to thank you for joining the webinar, and don't forget to participate in the survey immediately following the webinar. The contact information for our panelists and myself is available on the screen now. We do hope that you would see us all at the AWWA show in Chicago in June. We look forward to hearing from you. We will address all questions that we did not get to within the next few weeks via email. Then this concludes our webinar, Managing Water Loss Together, 3 Utilities Sharing Strategies and Lessons Learned. Thank you very much.